is remind you about the notes that we took on Friday. We had, remember the little graphic organizer? It looked like this. This one's not filled out, but it looked like this. And it was telling you about your p-values. Once you find your p-value, you're going to compare it to your alpha, or your level of significance. So if your p-value is less than or equal to alpha, then you reject the null. If your p-value is greater than alpha, then you fail to reject the null. Remember, we don't accept anything, we just fail to reject, because that's the way statistics works. All right, so let's do an example. So I told you we would actually work some of these today. So here we go. If a p-value of a hypothesis test is 0.0302, what would your decision be if alpha is 0.01? So we have p equal to 0.0302. So is your p-value less than or greater than? Well, in this case, p is greater than alpha. So fail to reject the null. In this case, where p is 0.0302, and my level of significance is 5%, or 0.05, in this case, p is less than or equal to alpha, so reject the null. I mean, that's pretty much it. You just compare the p-value. Now, I know you don't know yet how to find the p-value, but you will. All right, so first you need to calculate p-values. First, you need to calculate the test's standardized test statistic. Now, I want you to remember the word standardized. Back when we first learned standardizing. When we first learned standardizing, that's when we introduced our z-table for the first time. So just be prepared. That's where this stuff is all leading from and to. If your test is left-tailed, the p-value equals the area in the left tail. If it's right-tailed, it's in the right tail. So your p-value is in the tail. So that's, I'm going to try to keep that straight. If your test is two-tailed, the p-value equals two different areas. It's in the test statistics on the outside. Your p-values will be shaded on the outside. All right, so here's an example. Find the p-value for a left-tailed test with a test statistic of z equals negative 2.15. See, there it is. I told you a standardized test statistic is where we first introduced z-scores. And remember, they are standard deviations. A z-score is just a specific standard deviation that isn't a whole number. Well, sometimes they are, but it's when they're not always whole numbers. All right, so we need to find our p-value. Well, I'm going to first sketch my normal curve. And I'm sorry, I will try to put curves on most things. Pretend. And negative 2.15, well, negative 2.15 is going to have to be, this is not a very good drawing. Negative 2.15 is going to have to be like right around here somewhere. It's a left-tailed test, so that means I'm going to have this portion shaded. I could go to my z-table, because this is a z-test score, and I'm going to look for negative 2.15. So here's my z-table, negative 2.15, and I get 0.0158. So P equals 0.0158. Remember P for percentage or proportion, and that, remember, percentages and proportions always come from the middle of the z-table. We work from our outside in. We have the z-scores. Remember, they're on the outside of the table here, and my p's are in the table. Or you could use your calculator. And remember, this is a z-score, so we could do second, the distributive menu, and then it's a normal CDF, because it's a normal curve, and I'm going to negative 2.15, and you should get the same thing, 0.015777, or 0.0158. Okay, so